videos. Like I showed you yesterday, but just real quick in case you didn't see it, it is in your shared folder. It is under, see Ryle. It is under this folder. There we go, AP Exam Prep, Practice Exams, Solutions. But what did I do in a nice email? I gave you the link that goes straight here. So all 7 FR have the BC kids, their teams, and their coverage of each of them. Now pause real quick. I'm going to sneeze. I apologize, people on the microphone. I'm not going to sneeze. Great. So am I staking my life on every single word, every single written down fact, every single explanation these BC kids gave? No. I'm not staking my life on it. I'm not saying that they did not make any mistake in what they said, how they said it, how they showed it. But they did have the question, they did have a partner, they did have the solution guide, and they had access to me for any questions that they had as to why the answer was what it was. Once again, that doesn't mean they might not have made a mistake in what they said. You guys hear me in class. There are things I say all the time that I meant to say something different, or what I wrote, a plus instead of a minus, a times instead of a so keep an eye open for those. Don't just take them as gospel truth, because they're not the gospel. So anyway, coming back. So in class today, we could be going over clarification that you need from their video. Clarification on 2017, one of those 1 and 2s. We could be going over 2013, which for 2013, do you guys have videos? No, so that's a little bit of a struggle, right? There are no videos. Well, how are you supposed to even know if you get it right or not? What's at the end? The solutions, the solution guides for the AP scoring guidelines for all 6 of the FRQs. So ideally, is today for me just doing a whole FRQ for you? No. It's for you to say, this specific part of this specific FRQ, I don't get why, fill in the blank. Does that make sense? That's what this is for. Now, if we run out of questions like that, either you haven't adequately prepared for today as far as you don't have numbers 1 and 2 done on your additional practice, you haven't graded your additional practice, you haven't watched the videos for the original, then maybe it'd be smarter after we go through whatever questions are valid and are ready, maybe it'd be better for us just to work and you to pull out your phone to try the additional practice FRQs, or for you to grade the ones that you've tried, or you to put in headphones and watch the videos of the ones online. So if it's something where we run out of being productive, I don't want to just waste your time. Does that make sense? But if it's something where I can productively answer questions on 1 and 2 of either of the exams, I will. Is that cool? Okay. We can also peek back at any additional B questions. Period 1, I don't know. They said they had no other B questions they wanted to see. But if you guys have any B questions from 2013 or 17 that you've found, we can go over those as well. Now pause real quick. Does every single person need to be tracking with every single thing I'm doing today in class to answer individual people's questions? No, you do you. What do you need to do? Do you need to work on your additional practice exam? Get out your phone, open it up, and then go ahead and work on it. Do you need to be grading what you've already tried? Do you need to be looking at your mock exam and finding the questions that you have? Yes, 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 yes. Whatever there was a yes to, that's what you should be working on in class. Sound good? Okay. For tomorrow, what's the ideal?
Corrections.
You've tried all 6 of the additional practice, because you've already tried your mock exam, right? You try all 6 of the additional, whatever you haven't tried yet, hopefully just 3 through 6, but some of you maybe all 6. You have all the attempted FRQs, or all the FRQs attempted. You've graded your FRQs with the scoring guidelines at the end of your mock exam, whatever one is your additional. And then you've watched the videos for the mistakes that you've made. That's the ideal. Now, is everyone going to have all of that done tomorrow? No. That's why there's the grace day until Monday, right? You're not turning in the mock exam corrections or the additional practice exam until Monday to give you grace. But the more you have ready tomorrow, the more you'll be able to benefit from the questions in class. Does that make sense? Questions about logistics? All on the same page. Lisa. I actually have them all graded up here. For some reason, I keep on forgetting to hand them out in period 1. I don't even know why. So if you want, we can hand it out today, or we could wait until people are back tomorrow and hand it out. If you want it, you can come grab it, though. I don't mind. Your guys' piles. How many of you guys want your LTF 11 and 12s? Okay, I'll go ahead and pass them out. I don't mind. Okay, as I do that, you guys look at section B's. Look at 1s and 2s. Oh, this is going backwards. If anybody's absent from your group, just collect all their papers and put it on the front, and I'll come by and grab them in a little bit. Sound good? think this is right. So if anyone's absent, just pass it back up to the front or put it on the desk in front, and I'll grab it. Oh, Justin, you're over here. That's for Justin. And then, there we go. Section B, where FRQ is 1 and 2. And guys, legitimately, if you're like, I don't really have a question because I haven't really done what I need to prepare for today, that's okay. Don't ask me anything. But if you have something, I want to help. Riley.
86 on B on 2013.
Okay, 2013, number 86. Okay. Riley, what's going on if the derivative is positive? F is increasing, good. Let's just, as a class, let's try to stop saying the word it. And I catch myself too, but you guys probably hear me. I say it, and I'm like, oh, the function. Try to stop saying it as much as possible. But yeah, F is increasing. How about this clue? What's going on, kid? Good. Perfect. Good adjustment. If I can write it right. If F is concave down, what does that mean about F prime? Any ideas? Yeah. Because F prime's derivative, is negative. So I could also say that F prime is decreasing, which might be helpful. So I need F to be increasing at a decreasing rate. Does that make sense? So I need F to be increasing, the Y's to be increasing at a decreasing rate. So F to be getting higher, but by smaller and smaller increments because of this concave down nature. Now, right away, I can cross off those two. Why? F's not increasing. So now I'm down to these three. This is an older exam, so there were 5 options instead of 4. That's okay. As I look at this one, this is increasing by a constant rate. Because as x goes up 1, y goes up 1 as well. This is increasing at a constant rate. That would be no concavity. That doesn't work. This one is increasing by an increasing rate. And this one is increasing by a decreasing rate. Does that make sense? Yeah. Increasing but at a decreasing rate. The slope is getting less and less. Callie, you had a question.
2017, number 1C.
Perfect. 2017 FRQ number 1. This is a calculator FRQ. I have my calculator ready. And on C. Now, before I get to C, let me peek at it real fast. Perfect. On the calculator FRQs, this is just a general calculator tip. On a calculator FRQ, you almost always want to put the function in your calculator to use it at some point in time. That isn't necessarily what you do for the entire FRQ, but usually it's a good idea. So before I turn the page, I'm going to quickly get this function in. And as I get it in, guys, or even just Callie, what function is this? It's a function of velocity, right?
Yeah.
So I'm thinking about position. I have velocity, which is like the second derivative of position, right? I have plus 12 all over 10x cubed plus 3. Okay. Double checking I have it all typed in, or else things will be very, very, very sad. Got it. So velocity, I know a clue that the initial position of the particle is 7 at 0. So I have a clue. In part C, what it says is find the position at 4. Now, if you go back and read the beginning of the problem said the position at 0 is 7. How can I go from a position at 0 to a position at 4 only knowing the rate? To get to a final from an initial using a rate, I need integration as net change. I would say colored pen, highlight, make a big deal in your when you see, you think. When you see that you need a quantity at a time, and you have where the quantity started at 7, and you have a rate, always integration as net change. Integration as net change says, I will give you the final x of b or x of 4. If you give me the initial x of 0, And then, remember, every time you take an integral of a rate, you're getting back to a displacement or a change in of the original quantity. So if I know where it started, and if I can find how much it changed or how it changed over these 4 seconds or whatever they are, I will know where it ended. So at this point, I would just go ahead. Since you have this function in your calculator, don't do any of this by hand because you have a calculator. Write down what you're going to do, but then go ahead and just do your work back here where you do 7 plus the integral, which you can do math and then scroll down, or the alpha shortcut. Then I can go my 0 to 4. Since I put it in my y1, Callie, I'm going to go get that little y1 to make things easier on myself. And then type in my dx. And then here's what the AP guys want to see. Absolutely nothing else besides the answer of 6.71. You could either just do 1 and then just be like, I don't know, I'm paranoid. Great, you'll get it right. Or you could have cut off the 1, 1. Great, you got it right. Or you could have rounded to 1, 2. As long as you have 3 decimals, you're good. Now pause real quick. Looking back at the units. Doesn't give us any units, so I don't need to put like feet or inches or miles or anything like that. But if there were units, you would have to put them. Does that make sense, Ken? Cool. This would give you full points. Full points. Anything else I can help with? Yeah.
2013 FRQ 1B.
Okay. 2013, the Monday exam. 1B. Yeah. For number 1, first of all, can we just, now, whether or not you've done this FRQ, whether or not you have questions on it, just general AP strategy. If you see an area and volume problem, we know this area volume, the last chapter that we covered this year. Almost always, if they did not give you the intersection, you're going to need it. So the very first thing that I would do, just strategy-wise, I would put both of these in my calculator. And I would say, you know what, I'm almost positive at least one time in this FRQ, I am going to need to know where 1 minus x cubed intersects with no idea what just happened. You guys caught that right? I have no clue. Come back. Come back. With sine of x squared. Okay. When I graph, I think I'm in Zoom standard. If not, I should probably reorient myself. Pretty quickly we can see, ooh, that number 1, this is horribly disgusting. And number 2, we could zoom in just a little bit, but the long story short is we need the intersection. And as we zoom in, we'll see our intersection at this point. Now, strategy. If you look at part A where it says area, and I know that's not the question that you have, but if you look at that just real quickly, you'll hopefully figure out that top minus bottom is the easiest way to do it. And if it's top minus bottom, if that's how you're solving the area, you would need that integral in terms of dx, which means I only actually need the x value of this intersect, technically. And how? Well, help Naomi real quick. How would you stow this quantity to be able to use it over and over again? Quit first. So second mode. Does that make sense? Then hit use stow. Is that cool? So I had the intersection right here. Number 5. Go, go, go. Go. Did I just get rid of it? I think I just got rid of it. Sorry. 1, 2, 3. Got it. If your intersection is showing, you want to stow, but you got to get rid of this first. So you're just going to second quit. You're going to stow, and you're going to store it as, I would just say A to make things easy. Except I didn't stow it very well, did I? I guess I didn't do it right away. Now, could you write down this entire decimal and just use it over and over again? The answer is yes. This is meant to save time. If I do second, quit, stow, I think I hit too many buttons with my poor little smartboard. Now I'm good. stored as A. Okay, why am I saying that? Because at the very beginning of this FRQ or any area and volume FRQ, I would, to be honest, I would write this and I would give the intersection point letters. Letters that are not being used already in the problem itself. So I have 0.76497. Now, I'm going to find the y too, not because the y also, the y value, not because I need it for the first problem. The first problem really just needs x is 0 to x is a for its bounds. But I might need the y somewhere else. So I'm going to go ahead and wait, but you can't stow the y. It only stows the x. Pause. Don't I have the y just chilling in that y1? Couldn't I technically go over here and get y1 and say, haha, I want y1 of you, please. So I can go ahead and get that y1 value. Even if I'm not on the graph itself, I'm trying to save time so you don't have to keep on looking for that intersection over and over and over again. I have 0.5523. Now, I think your question, Naomi, was on B, right? Okay. B is weird because B says take this region, and I think it says horizontal line through the intersection point, right? Call it K? Okay. What is that line going through? The intersection point. What's the y value of the intersection point? So when that problem in part B says, hey, find the, or use the horizontal line that goes through the intersection point, even though they said K, it was really just B. It's that y that I already am able to find once I find the intersection point. Because it's going to be the same y value as the point. So I get to steal the y of the point because it goes through, they intersect there. I get to steal that y value. And once I have that y value, I have to address the question being asked. And the question being asked says, okay, you have this horizontal line. Let me get this point, that way we can have it. And it asks, will it split this region into two separate equal regions? Now, I don't remember exactly how this goes. I'll pretend it's something like that. We have an intersection point at A. Okay. The horizontal line is going to go through B. So right away, I can say, oh, sweet, you know what? K is just equal to that B that I already have, which is 0.5523, etc. I already found that. That's the y value of the intersection point. But then it says, does this line divide R into two regions of equal area? You have two ways of doing this. But if you look at it, well, first of all, my picture is horrible. Go look at the actual picture. Don't use the picture as your guideline. But if you look at your picture, you have your big old R right here. It's trying to say, will this horizontal line split it in half? Well, I don't know. I need to know that area. Well, how do I know that area? Can't we just do top minus bottom of that region? The top of this region is going to be B. The bottom of this region is going to be your sine x squared. And your bounds are going to be like letter A, 0 to A. So the bottom part is going to be this. Now when you go ahead and plug this in, and I could go ahead and plug it in pretty quickly just using my calculator. I can use my function integrate. I can go ahead and go down and hit number 4. I can go from 0 to A of B, sweet, I have him stored, minus sine of x squared. Oops, that's not what I wanted. Lo siento. Okay. This technically is all you had to do, and here's the reason why. In part A, you already figured out what the entire region was. So you could say, hey, if this splits it in half, wouldn't this have to be half of the region R? So I would have gone back and taken half of letter A and then compared it and said, are they the same? Yes, sweet, it splits it in half. Are they different? It turns out being yes, so it doesn't split it in half. That's one way of doing it. And that was actually on the answer key, the scoring guideline. That was comparing with letter A, I think was how they gave the point, but it says or. There was a second way of doing it. The second way of doing it is instead of comparing it to letter A, finding the other portion. So instead of finding the bottom portion, finding the top portion. I shouldn't say instead of. Also finding the top portion and saying, okay, well, that's for this guy, but what about for this guy? So he would be A1. The top would be A2, and we'd have to do an integral for him and then compare the two. Are they equal or are they not? This guy would have the top of the other function, which you guys might have to help me. Is it 1 minus x cubed? I think it's 1 minus x cubed. Minus b, minus bottom. And guess what, kid? When you compare the two, they are not the same, so it's not equal. So what I did is I took little piece by little piece, top minus bottom, and then I compared the two. Riley, you wanted C, right? So then taking my horrible representation of the graph, which is something like and something like, I have my R, there's my A. I'm revolving about y equals -3. If you guys don't like volumes of solids of revolution, you might want to peek up now because here's a good one. Unless you want to wait and try it on your own, that's totally fine. Riley, dx or dy? Good. Do you know why? Good. Because you can shade it. Good. So right away I know that volume, I'm revolving, so I'm going to have pi. I would put a big square, but why am I going to actually put little squares on the inside? What am I setting up for? Why is it a washer? Look at all that empty space. It's not flush. So if there's empty space, then I'm going to need to go ahead and think of big R, which can always be drawn from the axis to go towards the shading to the outermost. Then from the axis towards the inner boundary or the edge of the hollow. You could do something like call this one, I usually do little r, big R, but the problem is I already have a big R, so I guess we could call it something like R1, R2, I don't know. Because I already stole our big R for radius. So we could just do the big one minus the little one, and how do we do that? First of all, I need my, 0 to a, because it's dx. My big R, who's on top, kid? Good. And then who's on bottom? On bottom down here is sine of x squared. But who would be on the bottom of the big R? Or sorry, the outer radius. Got it. So you're going to have the 1 minus x cubed minus -3. That's who needs to be squared for the first radius. Second radius. Who's the top of that guy? The other function. Who's the bottom of that guy? Don't forget your dx. Some of you guys missed points by not writing dx's. You got those little check marks crossed out, so write your dx. And the AP would not want to see any other work besides plugging and chugging with the answer. You guys remember the scoring guidelines are at the bottom of these FRQs. If you want to go see what points you got for what work, etc., please check it out. Is there anything else I can answer?
2017, number 2A.
Okay. We're going to peek at 2017, the Saturday one, number 2A. Number 2 was the water tank one?
Yeah.
All right, this one was a little brutal. But there are so many calculus speak words to help us out. For a lot of us, if they give us a formula for rate, will work better if we make variables for the original quantities. What I mean is this little a of t is just how fast the water is going into tank A. But what about a variable for the water itself? Well, I'm going to go ahead and say, whatever, you didn't give it to me, but I'm going to do it myself. And I'm going to say W sub A of t is the water in tank A. Ha! Now technically, I should be a little careful with that. Maybe I should say instead, no, that's okay, I'll leave it. And W of B, just because then I have some variables to think about. I'll say that's the water in tank I work better when I have like variables to talk about things. So when I see this and I see rate of the water flowing into the tank at a rate of A of t, I can say, oh, hey, it's like W prime, W sub A prime. Okay, I know this is a rate of change of something. I also know that there is a rate for tank B flowing into tank B, and it's this guy. And they did not give me a function. That stinks, but they gave me a graph. Okay, all right. Both tanks are empty at time t equals 0. So I can say that W sub A of 0 is 0, W sub B of 0 is 0. And that shows me that they intersect at these 2 points. Okay, that's these little 2 points right here. So I could label the K, and I could label the 2.416. Okay, letter A. How much water will be in tank A at time t equals 4.5? We can't plug in 4.5 here. That's just how fast the water's coming in. I need to know how much water is in, giving how much water was there to begin with, plus the change in the water. What does that sound like?
Integration is net change.
You see it? He's an important one. He comes up all the time. I know how fast, and I know where it began. That's integration is net change. Because, check it, can't I just say, oh, how's integration is net change work? Final equals initial, which will be where it was to begin with, plus, and then how do I do this part? From?
0 to 4.
Good. Starting, ending. Yeah. Of?
A of t.
Good. The rate. And the rate for this guy will be A of t. Is that cool? So then what can I do? Well, I can use from my problem that the tank started from empty, so I can say 0. And then I can plug this guy into my calculator. Sweet. Boom. There it is. Wow.
Wait, so can you explain, like in simple terms, what you meant, like when you were subtracting what from what to figure it out?
For how I got the formula?
Yeah.
This is from my integration is net change that says I can find the quantity at B given the quantity at A, adding the change that happened in the quantity, which can be found from displacement, the integral from A to B of the derivative of the quantity.
Okay.
So I can figure out how much water is in the tank at 4.5, given how much water was there to begin with, plus the change in the water that can be found by the integral from 0 to 4.5, the integral of the rate. Because remember, when you take the integral of rate, you end up with W of 4.5 minus W of 0. You end up figuring how much change there was. Does that make sense?
Yeah.
Okay. While we're on this FRQ, any other questions?
Literally.
I don't know why they're green. I think it's just I ran out of paper. Which one? B? Yeah. This is a hard FRQ. I totally agree. And there is a video on it if you want a little further explanation. But letter B says, let me go take a picture of B. That way I can have it separate from A and still see what's going on. Okay. So then A A's info is right there for me if I need it. During the time interval 0 to K, water flows into B. Oh, they told me about B. Okay. Didn't they give me a letter to talk about the rate of B? B of t? So I can go and say, oh, well, you just told me who B of t was. Constant rate means that B of t is just equal to 20.5. Okay, fine. You could have just given me the equation, but you gave it to me in words. Okay, B of t is equal to 20.5. What is the difference? Math term. Math term. Difference? Subtraction. Between the amount of water in tank A and the amount of water in tank B at K. So they literally just want how do I do that?
Calculator intersection?
Yeah, you can do intersection because didn't they just tell me who this is?
Yeah.
This is 20.5, and then come back here and look and say, okay, well, wait a minute. If I know who, well, hello, that's a lot of wording. If I know this is 20.5, and I know this guy's, I can just graph them and find the intersection. If I find the intersection, isn't that k?
Yeah.
Okay. So when you find the intersection, k is equal to, did anybody find that k for me? I didn't know if someone already had it written down. Okay.
What are you plugging in for?
Yeah. Well, see how, Callie, this is the intersection between A and B? And A, they told me. And B, it was a little hidden, but they just told me who B is too. The rate of change of water into B, this is this guy. So what I'm trying to do is just graph the 20.5 along with the original equation and find that intersection. So I have my 2t, x's are totally fine, no stress, minus 5 plus 5e to the 2 sine of t. And then 20.5 is the other rate, so I'm trying to see where those two rates intersect. I already know the 2.4 yada yada yada, so I don't want that one. I want the first intersection point, which hopefully I will see right about somewhere here. Where is he? Why can't I see an intersection? Yeah, it's 20.5. I'm only going up to 10 right now. So I have to go ahead and change my window either by zooming or just making my y go higher. Let's go up to like 30. That'll definitely hit 20.5. Then I should be able to see this a bit better. There he is. See it? So I'm going to go ahead and go find my intersection. I can go ahead and go a little bit here. That's good. This is going to happen after one, so I could do like maybe 2 or something. My second curve. Struggle. I was doing zeros instead of intersections in my head. Okay, 1, 2, 3. 0.892. So I can steal that 0.892 and say, sweet, I know what k is. I think it was 0.4, something. Now hold on, wait a minute, but I need W of A there and W of B there. Wait, Callie, in part A, didn't we just talk about how to get W at a certain point? Yeah.
Again.
So I can find this guy by doing WA of 0. Wait, what is WA of 0? 0. Plus the integral from 0 to not A anymore, now it's 0 to K of my A of t dt. That's going to be my water in tank A minus, what's my water in tank B? Well, hold on, where did he start? He started at 0 too, so I could write the integration as net change, but it just starts at 0, no big deal. I'm going to subtract the integral from 0 to k of, they just told me, 20.5 is my rate. Plug and chug it to your calculator. The integral from 0 to k of A of t is equal, or sorry, subtracting minus difference, 0 to k of 20.5 dt. If this is a positive number, doesn't that mean that there's more water in tank A? If it's a negative number, there's more water in tank B. Does that make sense? Any other questions on 2013 or 2017?
I didn't even know how to do the next part.
Okay, the hard part on this one is that we are going to need to check out that graph. It's kind of annoying because you have to flip back and forth just a little bit. Let me just get the graph right here. They say something about a triangle, yeah? The area of the region bounded by the graphs of A of t and B of t in between k and 2.416 is 14. Oh, they told us who this guy is. Right? Between, from here to here, okay, that's 14.470. How much water is in tank B at time t equals 2.416? How much water? This is integration as net change, ultimately, right? Can't I say WB of 2.416 is going to equal WB of 0 plus, now here's what gets a little dicey. What did That's mine, I'm sorry. What did part B say that B of t was? Because I need to go ahead and plug in. And normally you just say, oh, go from 0 to 2.416, but why am I going to go from 0 to k and also from k to 2.416? What was the rate only between 0 and k according to B? So I'm going to use 20.5 for the part that I can use it, but check it, guys, it's only a line for a little bit, and then what's it start doing? Curving. So I can only use 20.5 for the first little bit. Then I have to go ahead and use, well, what am I going to use? I don't know who he is. I can plug that in my calculator. How can I plug this if I don't know? Wait. What did they just tell you about the area between? It's 14.470. Now hold on. 14.470. Doesn't that go all the way up to A? I need this guy. Who's this guy? Isn't it this guy down here? Isn't that what I need? Because I need the area under B, not the area under A. But here's the struggle. I don't have a B equation. So what can I do? This guy can be the integral from k to 2.4, that's a 5-minute bell, that's weird, 2.416. Can't I take A, the area under A, and subtract the 14.470? They told me how much area is right here. And that's the area that's on top of the B of t. So B of t is what I wanted. They gave me that one. I can find A of t using my calculator because they told me that function. So I'm going to take the A of t area, subtract that bit. Haha, now I have the B of t area. And I'm going to plug that in. So I'm going to end up with, at the end of all of this,
I'm still a little confused on how that gives you the area under B, though. Why would you subtract the 14.470?
because the area under A gets us all of this.
Oh,
But I need the area just under B.
okay. I didn't know it was giving you the whole.
Does that make sense?
Yeah.
So area under A gives the whole thing. So if I take the whole thing minus the top part, I'll get the bottom part. And the bottom part is my B of t that I need. Does that make sense? So I'm just going to end up with my 0 plus 0 to k of 20.5 dt plus k to 2.416 a of t minus the 14.470. Visually, that was a nasty one. But they made you dig into the concept. Not only dig into integration as net change, but also dig into, oh, an integral is area. Oh, I don't have that area. I have this other area. Then I can use the clue to get to what I want. At this point, let me go ahead and time out on 2017 FRQs just because it'll give you time to try maybe the rest of the FRQ if you hadn't been able to before, and to watch a video explanation with the BC kids explaining how they did. They had number 2 also, and a lot of them missed points on number 2 as well. So it wasn't just you guys, it was a hard FRQ. But for tomorrow, what do we want? Everything attempted. Everything graded. As many videos watched as possible. Come to me with, I've tried it, I've graded it, I've read the answers, I've watched the video if it's available, I still don't get. Does that make sense? Is that cool? Okay. Does everything have to be done tomorrow by the end of the day? No, you have grace until Monday. But the more that you have done for tomorrow, the more productive we can be. I think we have 4-ish minutes? 2-ish minutes? You guys want to take a breather before period 7? All right, let's do it.